Okay, very small intro. I suppose all of you know Petr Sokerin, my employee, PhD student, and a master in LLMs. And he will give a brief introduction on how to use transformers. I suppose it shouldn't be that hard for most of you, but to keep everyone at the same level, and for our assumptions that everyone knows something about LLMs to be true, we will conduct this seminar, and you can enjoy it as well.
Thank you, Alexei. Hello, guys. Well, I would like to begin with a question. So, who are familiar with LLM, who fine-tune LLM or just use it as a pre-trained model? Please raise your hand. Okay, who are absolutely not familiar with large language models? Okay, a bit. I suppose we have actually a lot of people not familiar with large language models in our online part, so our online colleagues will be interested in our practice. Actually, today our theoretical practice is a brief continue of yesterday Irina Piankovskaya lecture. So we would like to introduce the large language models and language models. So firstly we recap the LLM theory. After we talk a bit about inferring large language models, we introduce LangChain framework and brief introduction how to build a RAG system, and as a bonus, optional part of our seminar, we maybe try to fine-tune our large language models. So, first of all, the key part of large language models is attention mechanism. Attention mechanism include query, key, and value matrices, and this combining it in this formula. Query matrices we need to get information about tokens. Key information matrices we need to match tokens for key and query, and value to aggregate information according to some coefficient getting with query and query composition. So the production of key and query is a measure of similarity between the words, and we need softmax to get something like probabilities with big quotes or weight coefficient to aggregate embeddings. Are all of you familiar with embeddings? Who don't know what is embedding? Okay, nice. So this is the basic example of code how to train how to get an attention mechanism, self-attention mechanism. But if we would like to talk about large language model, firstly we need to talk about language models. Actually, large language models appear approximately in 2022, but before it we have some other types of models. We are called language models without a name of large. And the idea of mechanism, large language models, and language models are very, very close. What is the idea of LMs and LLMs? How can we work with it? Actually, we have different tokens or words. In my lecture seminar, we use these terms equally. If I talk word, it is an equal to a term token, okay? So we get some words, we get embeddings of these words, traditionally from embedding layer of neural network. These embeddings go to maybe the body of neural network, and after that we get the probabilities of the next word. The mechanism of generation is the next. We can generate some words, and after that we try to estimate the next words. For it we solve the what task of machine learning? Oh no? Yeah? Classification, yeah, thank you. We solve the task of classification with all our known tokens or words as a possible classes. So how much classes we can have in this task? Approximately 10 millions. How much? How many? Okay, 10,000 or a bit less or a bit more. Yeah, this task can be very, very hard for a model, but now we have a family of models who can successfully solve this task. Well, so we can introduce large language models. So language modeling is a conditional probability when we try to predict the next token. This is a W here, according to the previous tokens, actually, something like that. And how can we train it? We take the sequence of words, we estimate the word probabilities, and we have actually a target, a correct next word. And we just use a cross-entropy loss to predict next word. So if we have a next situation, the sentence I see cat in, sorry without articles for simplification, not very good English, but I suppose it can be much more easy to understand what is going on. We have a sentence I see cat in, we get some probabilities. I suppose we can see cat in the Mars. Actually, it's very hard. Today, 2025, maybe for listeners who watch us in 2050, see cat in the Mars can be easily, but now it is impossible. So we need to decrease the probability of the word Mars and increase the probability of the word window. So first we have a correct sentence and the word window was correct. So we need to increase the probability of window and decrease probability of all other words. So we can use the softmax mechanism for our beginners in machine learning. Softmax mechanism is work like this. We can use this formula, and V is the vocabulary size. So we need to estimate the probabilities of all our words, and Z is the logits. This is output of our neural network. If you are interested in, the much more detailed scheme can be seen in the screen. Firstly, we send embedding of our already generated words in our neural network. We get the text embedding, the embedding of entire sequence. We send it in linear layer, for example. We get any logits without some limitation about what meaning can be in the logit. It can be positive number, it can be negative number, it can be almost everything, and after softmax we can get something like a probability. Well, I hope it was clear for you, and let's start our practice. Actually, this is some technical cells to run this code. Oh, okay. Do we have any students who are not familiar with Jupyter Notebook or Colab here? Please raise your hand if you are not familiar with Jupyter Notebook or Google Colab. Okay, everybody familiar? Nice. So, first we need to import our modules. Today the main module is transformer package. Transformer is a package from a Hugging Face platform to run our models and some technical cells. So today we can know that we have a transformer architecture as encoder decoder, or maybe a separate encoder or separate decoder. So traditionally this architecture used for machine translation. Why can we use this model for machine translation? Firstly, we need to understand the original language, and after that we need to translate it in another one. So we need two parts as we try to translate our sentence in our head. Firstly, we read entire sequence of words. We try to understand what is going on here, and this is encoded part of our model. It gets the tokens in original language and try to reaggregate it with attention mechanisms. The second step, we need to generate new sequence. So we have our output tokens that are already generated. We send it to a decoder part with some links with encoder, and after that we get word by word or token by token. But for text generation, actually, we can use as an encoder-decoder transformer as a just decoder transformer. So in your favorite large language models, I sure absolutely all models are only decoder architecture. So if you have only decoder architecture, this picture is maybe not so good because here we should have not transposed embeddings, we should have a linear layer. We don't have a cross-attention mechanism like here. We don't have some enter from outputs from encoder model because we don't have encoder model. Actually, we have only embeddings, some positional encodings, masked multi-head attention, self-attention, and positive feed-forwards. And we have several blocks of this sequence. So, does anybody have question about theoretical part, maybe from online? If any hero watches at this point in time. Okay, let's go to a practice part. So, today we will use a QAN model. QAN is a series of large language models from Alibaba Group. It has different types of model. Actually, does anybody not familiar with Hugging Face platform? Please raise your hand. Everybody is familiar. Okay, maybe for some people from online, I need to show that we have a special Hugging Face platform where we can get any open source models. In Hugging Face, we have a section model, and actually we can find our model here. If we want QAN group, we can just find it. Okay, or not. Almost all accounts have different models. We have different models for different aims. And if we get to a QAN group, we can see that we have models of different generation. For example, we have re-ranker model, embedding model. This is QAN 3, the last generation of QAN model. We have QAN 2 models for maybe for math, for code, for some other purposes, and something like this. Actually, we can have Omni model. Omni model is mean that we can use this model for different modalities. We can have VL, what this means visual language models, that we can use for analyzing not only text but images. And we can use instruct part of our model, instruct version of our model. Instruct version is then our large language models specially tuned for using instructions. Traditionally, we can have not instruction version of our model and instruction version. The first step of training large language model is pre-training, when our model trained to generate new words. But it is not very useful because who know GPT-3 before ChatGPT, please raise your hand. Okay, who didn't know GPT-3 before ChatGPT? Alexander. Okay, some people don't know. Actually, GPT 1, 2, 3, and 3 were just language models without instruction tuning, something like this. These models are very useful to generate new texts, new sequence of words, but they were absolutely useful because, useless because we can use it for any other goals. Why? Because these models can't follow instruction. We need a special stage of training large language models, this stage called instruction tuning. So if you want to use language model to follow instruction, it's better to take instruction version of your model. Today we will use QAN 3 as non-instruction version, but this is okay for us. We now don't have QAN 3 instruction version. Actually, models are different in the number of parameters or size of model. Actually, large language models traditionally is very, very big models. I suppose we can call the model large if it have more than 1 billion or 7 billion parameters. Today, somebody can talk that we use not very large language models. Actually, we have a special term, small large language models. Actually, it sounds pretty interesting, but it's the fact. And what does it mean? We today will use the teeniest, the smallest model, but that work very fast. For your practical projects, I highly recommend to use much bigger models, but today I run every cell locally with a small GPU with approximately 40 or 45 gigabytes, and in the end of our seminar we have a fine-tuning of language model. So it's very hard to fine-tune in adequate time period language model with a bigger size. So small model can be not very intelligent, not very smart, but they work very, very fast. If you have an opportunity to use a bigger model, please use a bigger model. The bigger model is a model with bigger number of parameters. You can find a different version of models in Hugging Face platform. For example, Qwen 3, we have 0.6, 1.8 as I remember. Let's check. Qwen 3, yeah, here. Yeah, 0.6, 1.7, 4 billion, 8 billion. I suppose the adequate performance will be starting with 8 billion, 14 billion, 32 billion, and some bigger or bigger models. So let's come back to our seminar and let's download the model. Actually, when we download a model, we need to download not only the model, it's pre-downloaded by me. If you download a model, it can take several minutes. It depends on the size of your model. You need also download a tokenizer. Who doesn't know what is tokenizer? Okay, everybody know. Actually, very advanced seminar for you. Well, tokenizer is a special part of language modeling to transform our text to a tokens. Actually, we have an embeddings in our pictures here. But how can we get this embedding? In neural network, we traditionally have a special layer before the main part, the body, the code part maybe, or the code part of neural network, and this network this part of network traditionally called embedding part. Embedding part store embedding for unknown tokens. Every token have a special code, the ID. So firstly, tokenizer split a text in tokens. So if we have this sentence, we need firstly to divide it, to split it in different tokens. After that, every token have a special ID for your version of language model. So if I download maybe previous generation of Qwen model, or if I download a different open language model, for example, Mistral or DeepSeek, I need to download a special tokenizer for this model. Why? Because here the chat token ID, this is just an example, is 100. But if I take, for example, Mistral model, the 100 token can be sun or some other words. So please download a tokenizer. Tokenizer firstly split our text for different tokens. This sign means space here, and after that it can tokenize to get IDs of the words. Well, and we can send these IDs, we send to language models and generate output tokens. As you can see, in a Hugging Face, you have enter tokens, input tokens, and have output tokens. Output tokens here include input tokens. So we send a text, how are you? And the question answer. Question answer is a separate token. And we get a sentence, how are you? And some other words. How can we know these words? So we have a tokenizer encoder, and we can have actually a tokenizer decoder just swapping key and value in a dictionary inside the tokenizer. And we can decode our text. How are you? I am student and I have a problem. I need help with my homework and sama. Well, if you want to know how work tokenizers, I have a link here, and we have a special services called tick tokenizer. What we can enter here? We can enter a text and look how language model can separate it in different tokens. I will show example in English and in Russian. For example, let's enter London is the capital of Great Britain. So now you see that every word is a separate token. Can you see? Should I do something like this? But if you enter a text in a different language, this is a tokenizer for GPT-4o. If we enter this text in Russian it is only 3 words instead of 7 words in English. We can see that we have 7 tokens. We have special tokens for L, special tokens for Andon, special token for Stal, special word for Tsar, and Velika Britannia is separate in 3 different tokens. Why is happening? Actually, in this model, we have BPE tokenizer. It not separate text in different words. It analyze the frequency of different n-grams of symbols and group it in special tokens. The very, very popular words are grouped as words. For example, London in English is a token London, and Great Britain is a Great and Britain. But actually, every big large language models are multilingual. So it's trained in different languages. But what do you think? What is the most popular language in training multilingual language models? English? Yeah. For Chinese model, Chinese can be the most popular. For Russian models, Russian can be the first or the second popular language. Actually, as I know, we have only one Russian model fully trained with both stage on Russian, but not fine-tuned from different models. So it means that for not very popular language, it doesn't have entire words as a token. So if you use large language model for maybe Russian, maybe some other languages, it can divide your short text in much more tokens in comparison with English models. Is it clear? For online listeners, is it clear? Do you have questions from online? Okay, and here in this services, we have actually different models. We can check how, for example, Qwen 2.5 model can work with this. Let's check the same example. And we see that it works very nice with English. But in Russian, 3 words and 12 tokens. Actually, if you would like to optimize your large language models for your language, firstly, maybe the good idea is to update embeddings. Well, maybe for our Chinese colleagues, we can check some text from Chinese. Please, can you talk in the microphone? Very, very long phrases.
Actually, I've just did this with TikTokenizer. I've tried GPT-4o tokenizer in comparison with Qwen 2.5 tokenizer at Chinese names of countries. And that's interesting that GPT tokenizer would divide some of Chinese names of countries into 2 tokens, while Qwen tokenizer treats every name of Chinese country as a separate token.
Okay. So actually, there is one interesting fact that, for example, sometimes for a reasoning part, I suppose Maria Tikhonova today told you a bit about reasoning. Some models try to economy tokens and try to think in Chinese because it's very, very economic in the terms of tokens. So we need less tokens to generate text in Chinese in comparison with English or Russian, especially Russian. Actually, okay, one more question here.
Thank you. I have one question. If the model is trained on English, for example, can we somehow adapt it to work well in Russia in terms of tokens?
Yeah, actually, if we would like to adapt a large language model to a local language, for example, for Russian, is it correctly understand you?
Not exactly. I'm talking about the number of tokens. As you said, if the large language model and the corresponding tokenizer were trained on English, for example, then it's split Russian, when it is not very efficient on Russian sentences.
Yeah.
But can we just do some magic and make it work on Russian much more efficient, so with less tokens, and at the cost of, for example, English capabilities?
Okay, I understand you. Actually, first small part, large language model training both English, Russian, and actually many other language, but we pay much more attention for English. But in Russian, it works. If it wasn't trained in Russian, it absolutely not work for Russian. Can we adapt this model to get better quality for a local language, but maybe lesser quality for English language? The short answer is yes. How can we do it? Actually, in tokenizer, in embedding part, we have embeddings and tokens. Actually, we can add some tokens for our language and add not pre-trained embeddings vectors, and we can fine-tune, train, or maybe use pre-trained stage, okay, this model to train our new tokens. It helps us to save our time in the process of generation. This is a popular practice. Actually, some local Russian companies, for example, Avito, as I know, do it. Okay? Okay.
When you insert the amount of tokens to generate, how does it understand when to stop? Because we can clearly see that it does not do it randomly, so it always finishes at some finishing
We will talk about it.
Okay.
Okay, the last question for this part.
Yeah, we can see that tokenizer works differently with uppercase and without uppercase.
Yeah.
For instance, for London word, so tokenizer will work different if London starts with an uppercase. And why that? It's interesting. Just why model works like that? Because I usually when I write something to model, I don't care about it.
Actually, yes, because when our tokenizer trained, it separate all text in our train corpora in different symbols. So, firstly, London is separate as something like this. Actually, if we have London lowercase, it will be separate in different keys. After that, our model, when we train our tokenizer, check the frequency of different n-grams, the pairs of different symbols, maybe more than pairs, maybe pairs of different tokens. For example, it can group aggregate this token, after that maybe with this, and with this. So for a model, after different stage, this is only one token. And here, in this case, this is where only one token too. But however, we can see that L here and L here is a different sign for a model. It don't have an operation to get low capital. We don't lower every letter, and for tokenizer it's a different tokens. So that is why these tokens are grouped and these are not grouped. Because London with a capital E can be found in the text with much more frequently with London with a lower L. So for model, this is different words and different languages. Okay, the last question here.
No, actually, I would like to just address what Mark asked. It's a choice, a design choice of a person who designs the tokenizer. Actually, early tokenizers used all lowercase, and then it's just a regular expression. How you process your input data. You can just put everything to lowercase, or you can use regular expressions. You just with uppercase, you just catch more nuanced intricacies of the language. That's it. And just a little bit more of that, but it's absolutely design choice.
Yeah, this is design choice, but I told about modern large language model with BPE tokenizer. If you have just word tokenizer, you should lowercase or L every sign in your text. Okay, let's continue to the practice. Actually, we are here now. We get tokens. We generate some tokens.
Petr, I'm sorry, can I interrupt you with some questions from online chat? So the first question is how LLMs deal with punctuation. Do punctuation symbols have their own IDs during token ID mapping?
Yes. They have different IDs. Yeah, here you can see the separation for tokens. Here we can see IDs of tokens. We have different IDs for punctuation.
And another small question. Is it not checked with some algos before tokenizing, like Levenstein distance, to check the spelling?
No.
No. Thank you.
Okay. Let's continue with inference. Okay, now let's talk a bit about the inference strategy. Actually, let's take an example text. I am glad to participate in machine learning summer school smiles. And let's generate a text. Actually, okay, we can generate it and decode it automatically, or almost absolutely automatically. And I am glad to participate in machine learning summer school. I have problem with the code. I write then for this problem, the problem is to find the maximum value of function, and somehow we have a limitation of 50 tokens for almost all our examples actually. So we can generate any text, but how can we get it? How can we generate our text? The first strategy is greedy generation. How does it work? We have a probability of the next word, and we can imagine this tree. In this tree, we have a part of generated phrase. For example, here is I get, and after that, we have some other words. Every word have a probability. In my example, we have only 3 words. But how much words can be here? All our known tokens, actually. These 3 words is just an example. And every word have a probability written here. For example, if we use greedy decoding strategy, firstly, this is the simplest strategy that we take every step token with maximum probability. We have a phrase, I get. What is the next word according to greedy strategy? Who know? Okay, nobody know. The next word is cool because it has the maximum probability. Here is less and here is less. After that, we go in this part of our tree and we need to continue with a word sword. I get cool sword. Without articles, sorry, this is just for simplification. Actually, I suppose every boy dream about a cool sword. Actually, until 48. So, this is the greedy strategy. The advantage of this strategy is, this is very, very simple and deterministic. This strategy, if you use it, we need to send our input IDs. Input IDs we generate here, and we will use it. After that, we send to sample false, and actually in this model we have some other parameters. I will talk about it later, but if we use do sample false, we don't use these parameters, but we send the default values. And let's limit it with max new tokens. Oh, I promised to tell you about how can we stop our generation. Actually, we can have two situations. Firstly, we reach the maximum length, and we can set as researchers or data scientists. Secondly, we have a special token end of sequence. It's like a word, it's like a token, but it is a special token. We don't see here this token in our generation. It just means that our model finished to generate our phrase. Who doesn't understand this? Okay, everybody understand about end of sequence token. So we generate word by word, token by token, and when we get end of sequence token, we just stop generation. We can imagine it like we have a for cycle here, and if we get end of sequence, just we don't get in the next cycle of generation. Okay, this is about greedy strategy of generation. The next strategy is beam search. Yes. Micro.
Yeah, a small question to finally deal with this end of sequence token. How the model knows when to generate such token?
Actually, this token is here. Here we have all our possible tokens. Here we have out of sequence tokens. Actually, it can be generated as a next word. For model, it means just stop the generation. We will have a train corpora. We send this token in the end of sequence, and when we train our model, we train it to generate end of sequence token when our sentence is full, is ready. So it generated when it finished.
Yeah, so for example, if our current token is token that means point, for example, that it has a pretty good chance that next token is the end of sequence, right?
Yeah.
Thank you.
If model thought that our sentence is ready, it generates the next token, end of sequence.
Yeah, thank you.
Sorry. How does the model understand that, like, you pass 50 tokens that should be generated? How does it change itself so that it will have some meaningful ending before end of sequence?
It is not a model, it's a service. We have a model inside, and we run a code with generation, and it just hard code. If we generate more than max word generated, it just break the cycle. Okay, I can write a pseudocode for you. Maybe it will be clear.
But the ending was meaningful when you wrote this.
Sorry?
But the ending was meaningful when you wrote your text, so it didn't break at random token.
it break in random token if we get it. Okay, let me, where we was, guys, help me, here. Actually, in model, we have situation like this. For I in len, it is not like in this package, but this is the intuition. Oh, sorry, I shouldn't write it. I shouldn't run it. Okay. Model enter the previous generated token or input token here, and after that okay, for example, ID of end of sequence should be, this is just an example. This is the walk, something like this. Can you see it? Maybe I need to zoom in. Oh. So firstly we get an input sequence. After that we word by word generate new tokens. If we reach the limitation of max new tokens, it's just stop generation. It can be in the middle of a sentence. It can just not finish generation with text. And if we find the end of sequence tokens, we just stop our generation here. Do you see it? And we return our generated actually strategy. If we have a function, we can, not Python code, absolutely not Python code, but we can write something like this. All generated tokens with our input tokens. And it's like in Hugging Face, we can get our text. Actually, it repeats our input IDs, input tokens. Do you see it? Okay, let's continue. The next strategy is beam search. Why beam search is interesting? Because actually in this example, we can see that the group probability here, I get cool word. Actually, if we multiply probability of these two words is 0.25. But if we go here, instead of here, I get hot stone, where probability here is much bigger, and where our group probability is 0.36. So actually, if we take a group probability, not word by word, we should go here instead of here. Go to a green line instead of red line. Do you see it? So, what is the idea? We can use a beam search strategy. Every iteration, we can collect different number of beams with a higher probability. We can do it with several steps. This is not absolutely all steps because our memory in our GPUs will be absolutely empty. So, but we can use number of beams, and this is, we need set parameters do sample true, and actually we can fix number of beams, and we need to fix top K1 generation. This is, I will talk later about what is it, to fixed randomness. And now we can see that we have, I suppose, better text. I'm glad to participate in machine learning summer school, Smiles 2023. I am very excited about the opportunity to learn from the experts in the field. I also very excited about opportunity to learn from experts in the field and our. The text is not very good because we use very, very small model, actually. You can use ChatGPT with API or some other models or DeepSeek model to get better results. But I suppose it would be better to show example that can be stored in one GPU. Okay, actually now we have a lot of repetition, and we can fix it with a special parameter, no repeat n-gram size. If I run it, maybe the quality of our text can be less, but it don't repeat some phrases every time and every time. I am glad to participate in Machine Learning Summer School Smiles 2023, and I am very excited about the opportunity to learn from the experts in the field. I hope contribute to the development of machine learning community and to make meaningful impact on the future of AI. Please let me and some others. As you can see, our not very clever model, in previous example, generate expert in the field several times. But if we just don't let model generate the several text many times, we can get better text. Okay. The last and the most popular strategy is sampling. Sampling is when we, every step, take not the most better words, but the words with different probabilities. Actually, we can imagine that we have a coin, and we every time have a random coin experiment and get every side of coin with different probabilities. But the number of sides of coin is number of our words. Actually, the advantage of this strategy that we can get some creative and diverse outputs, but it can be a bit less controllable. Okay, let's seed our torch package and generate a text. Here we deactivate top key parameter to get just random generation. I am going to participate in Machine Learning Summer School, but I am not sure about exact training data used for the model, and other. But we can generate different samples, and we can see that for all our samples, we generate different text. Here we took part in Smiles. Here we took part in Smiles 2024. Here we took part in Smiles. But after that, in the first example, I am not sure about exact training data. In the second example, I think this is good opportunity. And in the third example, I have a lot of questions on this project. Do you have a lot of questions about projects? Yes. Okay. I suppose this model can be you. Okay. But how can we control our randomness? We have several parameters to generate our text. First parameter is temperature. Tomorrow somebody asks a question about the temperature. Today is explanation. So we use a softmax formula to get the probabilities. But we can control these probabilities with extra parameter called T, temperature. If T is close to 0, we get a greedy decoding. Traditionally, people used temperature approximate 1 or a bit less to get just probabilities. If we get the temperature higher, we get a more creative text, but if we have very big temperature, it will be absolutely random text. So here I draw a plot with the probabilities for different situations. We have different outputs, and with T 0.1, almost one word token A have the maximum probability, other have less probability. For temperature 1.5, this is originals of max. We can see that the first token A have probability 0.63, the second 0.23, and the last 0.40. And if we have higher temperature, our probability is much equal. Do you see it? Actually, let's see an example. Let's go and generate text with 3 probabilities, and for every temperature, we will generate 3 texts. Okay, temperature 0.3. It's just very close to greedy greedy generation. I am glad to participate in machine learning summer school. I am a student who is interested in machine learning. I have a problem with write code and I have problem in my research. We can see that every text is pretty close actually. If we have an hour one example with temperature 1.0, we can see that I need some insights about machine learning in the first generation. The second generation, we have the next paragraph actually, and in the third generation we have approximately something like in the first example. And if we have very, very high temperature, we can get a mix of languages. Actually, this is a very popular problem. If we enter very, very high temperature, it's just close to random generation, and can we get tokens from different languages. For example, I am sure that it is Chinese. We've mixed in English. Actually, if you generate text in Russian, you also can, with Clan models, with very, very small model and very, very high temperature, it's just close to random generation, can get a mix of Chinese tokens and Russian tokens. So please don't use very, very high temperature. Actually, now it looks like that we every time should set our temperature to a very low meaning, but if you want to get some creatives, for example, for marketing purposes, for generation film scenarios and something like this, you should increase your temperature. Maybe greater than 1, but less than 2, maybe 2. Okay, do you see it? Some other parameters, our top key, very, very popular. How can we use it? Actually, we can sample not from other words according to probabilities, but we can sample from top keywords relating the probabilities. How can we get it? We can get some distribution of word probabilities here. After that, if we take top 1 sampling, we will take only first token. If we have top 3 sampling, we will select one of 3 token, and top 7 we will select of top 7 tokens, but their probability will be related, as we can see in the green histogram. Okay, let's check what we get if we do this. If we have top key equal to 1, all 3 texts are equal. If we have top key equal to 10, texts are not very diverse but very close. If you have top key very, very big, the text have much more diversity actually. And we can have top P parameters. This is very, very close to top P, top K. So it's just selection connecting with probability. Actually, if we have P equal to 0, we take all our tokens to sampling. If we have very less P, we take much more tokens and some other and others. So top P with a number, this is where grouped our probability that we need to take this word. So if our top P is less than probability of a first token, we will take only the first token. If our top P probability in sum is equal to first 3 tokens, or maybe a greater, we will take first 3 tokens. If our top P probability is equal to first 5 tokens, we will take first 5 tokens. Do you see it? Is it clear? How can we get 0.5? This is 0.4 plus 0.24. This is 0.64 plus 15 and other 2 numbers. And after that, the sum will be greater than 0.9. But if we drop this token, the sum will be less than 0.9. And after that, we just regroup it to get the sum of probabilities is equal to 1 actually. And generate these tokens according to these probabilities, regrouped. Okay, let's look at the example. Top P probability with very less meaning is almost equal to a greedy generation. 0.7 is bigger, is much more diverse generation, and bigger, it's just without any regularization. Okay, and actually as a bonus, we can add some special penalties for repetition and some other parameters. For example, if we repeat some tokens, we can not only use, like in beam search parameters, number of engrams, we can use a special penalty that we apply to a generation to make our generation much more diverse. Okay, in the first example, with our repetition penalty is less than 1, we can see that number of word sum is 5 or greater. In the second example, we have only one word sum, but some words can be repeated, machine learning. And in the last sample, if we have very big repetition penalty, we have only one phrase, machine learning. After that, our model talk that it like AI and neural network instead of usage term machine learning. So we can use it. Okay, I suppose the last part of our seminar. This is about transformer package and text generation. But what if you would like to get a service? Actually, there is a very interesting framework, LangChain, that you can use for get different popular services. This is framework used especially for chatbots, agents, or rack systems. Today, different speakers mentioned rack systems yesterday. And today we will look at this. Okay, we can use Hugging Face model, but package very frequently updated, so this method can become out mode. So what we do now, we use a pipeline from our transformer package. We send it model, tokenizer, and some parameters of a sampling. After that, we use this pipeline to get a LangChain Hugging Face pipeline generation. To get one text generation, we can use the invoke method, but actually, if you have different samples, you can use batch method for generation. Actually, this is just another package that looks very close to transformers now and take different times actually. I ask the capital of United States and it took the capital of United States and Washington DC and some other texts. Actually, our model is not very clever and it's, I suppose, generate a test about what is Washington capital. But we can use something like system prompt. System prompt is a special prompt for your model if you use, for example, DeepSeek model or some other model as a service in a web version. After you enter a text, your language model, for example, DeepSeek or ChatGPT, get a system prompt. System prompt is a special instruction to the model to explain what the model should do. As a user, I wouldn't see system prompt. As a developer, as a programmer, I will see a system prompt. So we can get some templates for a prompt, enter the system prompt, and input from a human. Input of a human is capital of the United States. And model can generate some outputs. Actually, it generates not only text, it generates some additional parameters. And let's run the small example of chatbot. Actually, I will send this seminar and you can practice with it by yourself. For example, we can ask capital of United Kingdom. The green is some LangChain instructions. It gets system prompt and it gets human prompt, human request. After that, it repeat the system prompt and equation because we use now Hugging Face model. But if you use any different model, it wouldn't repeat it. So it told yes, the capital is the London and some other text. And we can ask any other, for example, capital of the Moscow. Oh, sorry, of Russia. After that, it get now not only system prompt and my request, it get the previous dialogue. You see, it get previous my question and previous answer of this model. This is how chatbots works. It get for generation not only your instruction, it get firstly system prompt and previous history of your conversation. Actually, if you want to generate something like chatbot, you need to do it. But actually, please write extra code to drop different text. Okay. Actually, we have very small model, and I'm confused here between UK and Russian because firstly we ask about United Kingdom and now we ask it about Russian. So if we use much more clever model, we can just fix it. And here, very popular question, how can I finish my dialogue with a model? Actually, if you write with services, very simple code, how can you write with service? We can enter a special phrase, hard-coded instead of model, before the model, and we go out from our chatbot or dialogue. This is how you can test your chatbots. Okay, and a couple of words about rack system. Does anybody doesn't know what is rack system? Who don't know what is RAG? Okay, 1, 2, it's absolutely okay to don't know. Well, actually, as you can see previously, our model just failed. We've told us about the capital of Russia. So our models trained in the data. As you can see in previous examples, almost all generation starts with, we have Smiles Machine Learning School 2023, but not 2024. Why? Maybe the reason of it is that, and nobody told that we have some schools 2025 actually. Now, why? Our model trained in the data corpora. Data scientists collect all internet and all text to a special date. After that, they need approximately a couple of months, maybe a half of year, to pre-train our model, and after that fine-tuning, testing, and some hours. This process can take more than half of year, maybe a year. So this is very hard process. And when we get a finished model, he knows information in the beta case to a date when we collect our data set. So if we want to enter the much more relevant data in our model, we have two options. Maybe more, but now two. Firstly, we can fine-tune our model. Now we have a very small model and we have an opportunity to fine-tune it. But I have here very big GPU. Not very big, but big GPU. If you don't have an opportunity to fine-tune the model, or if it is very expensive for you, it is a very popular reason because this model is 0.6 billion parameters. Who remember what is number of parameters in DeepSeek model? More than 600 billions or 400 billions, approximately like this. So how many GPUs do you need to fine-tune DeepSeek? A lot. And this GPU costs very much. For example, you can't use GPU, for example, for play. What computer games play now? Cyberpunk or something like this. You don't use your domestic GPU. You need a special production GPU like Tesla A100, H100, H200 and something like this. And they cost very much. You can render it actually. Our next speaker present you how can we do it and present it. How can we render GPU? Yes? A bit. Okay. So fine-tuning is not the easiest way to send the new information to the model. we have much more easiest way. It's called retrieval augmented generation. It have 3 words. The first word is retrieval. Actually, when you use RAG system, we have a base of knowledge. It can be different documents with actual knowledges. After that, we take only relevant documents with a separate special model. I will talk about it later. After that, we enter in the prompt parts of these relevant documents, and we literally call to our LLM, please answer this question, possible answer can be here. And after that, the model can generate the text according to the context or possible answer that we provide to this model. So we use just traditional pre-trained LLM, but we fixed a prompt for this model. How can we do it? Actually, firstly, we get a query or prompt. After that, we go to document store, finding relevant documents, and send it in our prompt. And after that, we get a response. Okay, let's see how can we do it. We need to import packages, and after, let's take a model. We will use the same model actually. And we need to get a document database. Actually, we can use web downloader to download 2 articles from Wikipedia. Wikipedia, for example. It can be articles about artificial intelligence and the article about Petr. Can we use much more documents? Of course, yes. Actually, RAG system can include 100 or more documents. And you can download it from PDF format, from web format, but I highly not recommend to download with web format something like AliExpress, Amazon, and other web platforms with dynamical changes information. Why? Because we get the page from a hyperlink and we do it only one time. So we just download the web page as a document. We can look at the document now. Actually, we have different docs. It's 2 now. Let's check. Yeah, only 2 documents. We can take the first one. And docs, of course. And it have a special format. Okay, we have metadata. Actually, if your documents include pictures, for example, you can store it in metadata. And we have title and page content. And we can look at the page content and we can do it here. So we can see the Wikipedia article. The part of it may be not very beautiful. Let's look at another part. Yeah, here it's some text about AI. Actually, the first document is about artificial intelligence. So the next step is splitting. Why we need to split it? Because the length of our first document is more than 200,000 symbols. It is very, very big document, and our models can hardly take the information from this doc. Now one point, if we send this document in a prompt, we can reach the limitation of a large language model context. Actually, our large language model can't work effectively with very, very large context. So the next step of our RAG system is splitting our documents in chunks. Chunks is a small part of a document. Traditionally, we can send the chunk size is 1,000 symbols, but it can be less or more. It depends the structure of your document. If the idea in your documents can be stored in 2 paragraphs or more, it's a good idea to make a chunks greater. If you have very, very short phrases or sentences, it's a good idea to make chunks less. We can split our text in chunks and get number of chunks 421, and the size of the first chunk is 1995. Why not 100? Because it is a recursive character splitter and it's splitted not only according to a size and according to special symbols like the next line or punctuation. Okay, after that, we need to make a special data store for this system. How can we do it? Firstly, we need to encode all these chunks. We will do it with a special model. It can be called retriever model or embedding model. What is the aim of a model? We need to find relevant documents. But how can we do it? Actually, we can have an embedding vector of a meaning. Embedding is just vector of meaning of a text. And we can get a vector of a query. And we can match query vector and our chunks vectors and find only relevant vectors. But to get embeddings of query and our chunks, we need a special separate model. Actually, you can use your large language models, but it is not obligatory. For example, you can use another model. It traditionally can be encoder model instead of decoder model. So here it is a paragraph multilingual mini LM model. Actually, you need just a model that can help you to generate embeddings. If you use API, you can use API from your large language models. Almost all large language models, big large language models, can generate you embeddings. And if we told about a price, embedding generation is traditionally cheaper than text generation. So we get another model. It's a sentence transformer, something close to a BERT. And after that, let's get embeddings for all our chunks. So we have text. For every document text, we get a chunk page content. So we get only text information from our chunks. And after, we send it to our retriever model. And very rapidly, we get the matrix of embeddings of size 481 and 384. Why this size, guys? Do you have an idea? Why 481? Yeah, without number of chunks, yes. And why 384? Hidden size or embedding size. Can we regulate the embedding size or hidden size? How? Use different embedding models, yes. But if we want this embedding model, can we increase the embedding size here? No. Why? Because we use pre-trained models and data scientists set this number of embedding in the train stage of our retriever model. Okay. Actually, after that, we can generate a vector database. I will use phase package for it. And traditionally, we can use cosine similarity, but for this example, I will use L2 similarity, L2 distance. Actually, now it's not very important. After that, I will create a retrieve function. In retrieve function, I will get a query. I get a vector of a query, and after I send this query embedding to my vector database to efficiently find top k closest neighbors. Actually, it will also return a distance. If you use cosine similarity, you can add filter to the distance. You can do very different manipulation actually. But I just send query and get k relevant documents. Let's look at the example. What is AI? I will send it and go 3 documents now. First, documents. Glossary, artificial intelligence is the capability of computational system to perform tasks typically associated with human intelligence and blah, blah, blah. Somehow. So, is it relevant or not? Okay, is it relevant or not? Guys, don't sleep, first lesson. Who think that this chunk is relevant? Who don't think? Okay, why? Why don't? We have the definition of the artificial intelligence. We send the question, what is artificial intelligence? And it firstly return us answer, what is artificial intelligence? Is a very relevant chunk. And we have 2 other chunks here. So after that, we now know how we get relevant documents. We can have a system prompt like here, a template. Answer the question based on following context, and here we will send the contents, our relevant documents texts. After that, we provide a question, and the question will be what is NNA, like in our example. And we can send it and get a prompt template like this. Answer a question based on following text, and we just send a context. Actually, I highly recommend to clear your chunks before storing in vector database, but now we have an introductional seminar, so we will not do it. Actually, we do it, and after that we have a question and an answer. Answer is a command to large language models to generate the answer. So we can group it in our LangChain framework. We can do it like this. We will get firstly context, send context from, get a context from a question that go to retrieve function. The retrieve function here get a query and a key, but we fixed our key in the value of 3. And after that, the results will be sent to format docs function. This is function that get the list of our docs and get a page content from it. After that, we send our question in the prompt. In our prompt, our context and questions will be sent here. Go to LLM, and we will have output parser. And let's test our systems. So, unfortunately, it repeats the prompt with Hugging Face model, but after that, it generates the relevant answer. Actually, it answers that AI is the capability of computational system to perform tasks typically associated with human intelligence. This is just information from the first chunk here. Is it good that our RAG systems answer exactly as in the chunk? No. Or yes? Who think that yes? Okay, 5 hands. 6, 7. Who think that no? 2, 3, 4. Okay, actually, this is good that our RAG system answer like in our chunks. Why? Actually, it should take the knowledge, take facts from here. It's just a mechanism to fix hallucination of large language models, and after that it can send us information or a bit reformulated, but it should answer us not according to knowledge of large language models, but according to a context. Because large language models can know irrelevant information, but we send it relevant information in our context. Do you see it now? Is it clear now? Yes, thank you very much. Okay, we have 1 minute and a bonus part. I just send you a seminar, how can we fine-tune large language models. It's not an efficient fine-tuning like a LoRa. It's just an example of fine-tuning. Actually, okay, a bit more. I downloaded datasets with a teeny story. I take only 5,000 teeny stories. It is absolutely small and not enough for tuning large language models. But just for example, we have not very clever large language models. And if we ask large language models before training to generate some stories starting with once upon a time the dragon flew and in the castle, it generates mathematical task starting with these phrases. Is it good or not? How much time we want to get a mathematical task when we send a prompt, the dragon flew? Oh, okay, now this is, looks like a story actually. But here it is. In the castle of Elbera, there are 5,000 gold coins. Actually, we don't want to get a mathematical task. So I send my model to train and looks at the end, how can we get it? It will be only 3 epochs with very small batch size because of you can easily get GPU limitations. And I suppose if you are familiar with machine learning, you can easily understand what is going on here. Actually, as you are familiar with machine learning, maybe with PyTorch packages, but not with transformer package, you will know that you need to write a training loop. The transformer package let you to not write training loop. You just send training arguments and call a trainer from a transformer package and just run a training process. You don't need to generate too much code, so now our model is training. And while our model is training, the data scientist can answer the question or drink a coffee. Coffee we can drink because we have a lecture now, so let's answer Mika's question. Do you have any questions, maybe from online? Online question, no. Okay, offline questions? Okay, just wait in the silence how our model trained. Okay, and kindly remind when you aggregate your, formulate your question in your head that after our classes, you need to go to Irena to write your name in the list to know that you're here. Questions? So guys, if you don't
So we have a question from online. How many documents can I use for a model in the RAG approach?
How many documents can we use in RAG models? Actually, traditionally we don't have limitation, but you need to know to understand that when more documents, when more chunks, then slower the process of finding a relevant chunks, the first point. The second point is harder to find a relevant chunk. Actually, it's much more easy to find relevant chunk if you have 400, and if you have 40,000, it's much more harder to a model. So we don't have any limitation, but if you prefer to add something like a size of one piece of from Lev Tolstoy, it may be not be a good idea. Actually, large language models know one piece from Lev Tolstoy very well, actually, without RAG systems. But if you want to add 100 documents, is okay if your RAG system works correct. In time you want, it works.
Okay, thank you. Yes, thank you.
Okay, our model can be almost finished of training, and let's look at the results. It just needs some time for finishing. Actually, it stored logs. You can open it with TensorBot framework. Actually, in results, you can collect a checkpoint. Checkpoint is the weights of your models. So I highly recommend to store some weights before finishing of the training. And we have here some metrics, perplexity and loss. And perplexity and loss is not very popular. They are popular for training, but actually when you work with generative text models, it's much more effective to look at the result than look at the metrics. And here we can see that we now, after small training, don't have text connected with mathematical task. In this now only short story text. In the castle, there was a bigger chamber and something like this. So, and our loss and perplexity decrease a bit. So that is why sometimes fine-tuning is maybe a good idea, but if you have bigger model, I highly recommend to use a bigger model, because now we have only a demonstration example. Please use some much more efficient methods of fine-tuning model if you do it, if you want to do it, like LoRa lower rank fine-tuning, and something like this. So, if you don't have any question, thank you very much. Oh, you have a question, okay. And online questions.
Can I ask you a little bit philosophical question about what have a more bright future, RAG or long context window?
Sorry, what if you have a RAG and a low context window?
Yeah, well, can you compare long context window versus retrieval augmented generation in terms of quality?
This is two different things for two different goals actually. RAG is for, you can have a small context with a large language model with a part of RAG. Nobody prohibits you to use RAG system with low context quality. I am not sure that it will be work very good if you have very big chunks, but actually RAG is this is a chance for a model to fix hallucination firstly, secondly to add some extra external information to this model, and I don't know how low context quality can do it. It can be help a bit with hallucination, I suppose, but I'm not sure that it is very, very effective method to fix the hallucination problem.
Okay, thank you.
Okay, online question?
Yes, we have online question. Yesterday, importance of documents uniformly for RAG was noticed. Please share the experience. Is it a good idea to use, for example, document in different languages, or how their structure may differ?
Let's repeat the question, please.
Yesterday, importance of documents documents uniformity for RAG was noticed. Please share the experience. Is it a good idea to use, for example, document in different languages, or how their structure may differ?
Okay, so look, if you have a retrieval multilingual model like us in our seminar, it can be not very bad idea to use multilingual documents, and it can work correct. Actually, one time I used to use a RAG system with documents in English and question in Russian, and my multilingual model, actually this retrieval model, like in our classes, work correct actually, and our LLMs, large language model, translate just English documents to a Russian. It can be a bit confused for different cases, but if you have nice retriever model and nice large language model, I didn't see big problems, but you need to experiment, especially with your data and with your models and with your limitation system. Actually, you need maybe GPU for retrieval model, but actually this is much more smaller than language model or language model. You need large language model, and if you would like to run locally, the small model cannot succeed with this task. If you use API or, for example, retriever locally LLM as API, it can be good.
Thank you.
But better to have actually it in one language. If you have an opportunity, you can do it. You should do it. That's all? Classes. Okay, I suppose it will be the last two last questions.
Yeah, thank you for the presentation. I would love to ask the question about explainability of RAG system. What are the approaches to define what exact chunk was used in the generation of exact phrase? So, for example, we retrieve 5 chunks, and we use like 2 or 3 in the actual generation. How do we define which chunk we used in the generation?
Actually, we can understand it if we don't go to weights of large language models and don't see attention matrices. Actually, we just send it as a prompt, and it works like it works. We can look at the prompt, we can just maybe look at the attention activation mechanism, something like this, but it's almost like sending the war and peace in large language model, ask a question and try to understand what character it used to do it. Actually, you can try to enter in a system prompt, return the number of chunk, but it can be, it can hallucinate actually.
So when we are using inference from like OpenAI, ChatGPT, we can't reliably decide which
You can ask a ChatGPT model what chunk do you use. Actually, I highly recommend to delete it for final user information. The user should know that you have a rack system. Almost, I suppose, not everybody user can know what is a rack system. But you can ask the model to generate it, actually. And I see it as maybe the best way. I highly recommend you to ask this question to maybe some other speakers, and they can have a different answer, but I think it is not possible if you use the ChatGPT model.
Okay, thank you.
And our last question.
Thank you, Professor. I have a question to ask for you. And since if a model uses rack system and there's something about the file, the knowledge in file is not the same as as the model's memory, and you think the pre-trained model have some memories that it remembers the capital of the UK is London, but the rack system, the file in the rack system said that the capital of the UK is New York or so on. So which side would the model trust? Actually,
We can't strictly control it. This is a very, very good question, actually. Because if we have collision, maybe different facts from knowledge of large language models and information from a rack system, we need to add information in our rack system prompt. Maybe where it will be, it was here. Please answer only following the context. In this case, I suppose we thought traditionally that our rack system contain relevant knowledge and large language model contain irrelevant knowledge. That's why, because actually almost all large language models think that the last president of USA is not Donald Trump, but previous president of USA, Joe Biden, because just a lot of weights was not updated since that time period. So we need to write strictly in this prompt that please use only information from a context, not from your knowledge, but it can hallucinate, and this is a problem. So it is not 100% guarantee that it use a context, but we increase the probability that our models return us relevant information, if it is in chunk.
Okay, thank you.